Hello, my dear friends. My name is Srilata. Today, the topic of my presentation is all about testing hypothesis by applying student t-test. Okay, now let's move on to the introduction part. Introduction. See, we are going to learn to use of a student t-test. Okay, this test was introduced by Gosset in the year 1908 under the pseudonym student. It means that this particular test was discovered by Gosset in the year 1908. Okay, and now let's see why it is used. It is used to test difference between two means, whether the two mean values are significantly different from each other or they are close to each other. So this aspect we can analyze by applying this student t-test value. In this case, the samples are drawn from a normally distributed population. Okay, and there should be randomly selected data. Randomly selected data, and so these are certain characteristics of it. Now let's see types of a t-test. These tests can be of three types. The first one is single sample t-test. Okay, now let us see what is a single sample t-test. See, the mean of a simple data is compared against a given or hypothetical mean. So that will be single sample t-test. That is, we have a sample and we shall be calculating mean value of that sample, and it will be compared with population mean. And next, second one is independent or unpaired t-test, where two independent samples are compared for the difference between their mean values. And the third type of t-test is dependent or paired t-test, in which a single subject is analyzed twice and then mean value obtained in both the conditions are compared with each other. This is called as a dependent or a paired t-test. Now let's move on to the meaning. If the sample size n is less than 30, that is n is less than 30, it is known as small sample. A study of sampling distributions for small samples is known as sample theory. It means that when sample size is less than 30, it is called as a small sample. Okay, fine. It is if it is 30 or more than 30, then it is called as large sample test. You all know that, right? We use it when sample size is smaller than 30 and sigma is not given. When sample size is smaller than 30 and when sigma is not given, then we use the t-test. Here n should be less than 30. It should not be equal to 30 also. Sigma is not known means population standard deviation is not known. Okay, it is called as a student t distribution, but we generally call it as t distribution. Fine. In this presentation, I am going to explain about the single sample t-test. See, it is single sample t-test can be calculated by following formula. Okay, as you all can see the formula. T is equal to x bar minus mu divided by standard error, where this x bar is mean of the sample. Whatever sample is given, that sample will be used for calculating its mean value, and there will be a hypothetical or a population mean, so that will be indicated by mu. Okay, that value will also given. Then to calculate the standard deviation of the sample, and n will be size of the sample, that is number of observation. in the sample. Okay. Here standard error is calculated by standard deviation divided by root of n. That means standard deviation is calculated by using the formula which is a square root x minus x bar. It's a square divided by and n minus 1. By using that formula we can find out standard deviation. Okay. So let us see how this formula is used in a particular sample. Here a particular case is given. 10 persons were randomly selected from a population and their hemoglobin content was measured. The values of their hemoglobin content are as follows. These are the values like 14, 12, 13, 15, 14, 14, 11, 12, 10 and 11. If the mean hemoglobin content of the population is 12, then find out that the mean hemoglobin value of the sample does not differ from the population mean. Okay, so it is very simple. You know the case, that is you have a sample data and from this data you will be calculating the mean value and standard deviation value, and you have a population mean that is 12. Okay, so you have to see the difference between this sample mean and the population. What we shall do is we have that all these individual cases, that is 10 values will be added with each other, and in the present case the total comes to 126. Okay, by adding all that numbers we get a total of 126. Since 10 individuals have been analyzed, so 126 divided by 10. Okay, fine. It will come 12.6. So the mean or x bar that comes to 12.6. So 12.6 will be the mean value, that is sample mean, which is being indicated by x bar, and by using the SD formula, we have to use SD formula by which by using the SD formula, which is a square root x minus x bar, it's a square divided by n minus 1. By using that formula we can calculate the standard deviation also. In this particular problem or in this sample, and it has come in the present case 1.65. Okay, number of observations are 10, and here the mu value is 12. Okay, mu value is 12, that is a population mean. So we are putting all these values in the formula. So x bar means 12.6 minus 12 divided by 1.6, that is SD value or standard deviation value, and this will be divided by square root of 10. Fine. When you will calculate this the final value will come, that is t is equal to 1.149. Okay, after getting this t value you will have to see degree of freedom. Okay, and degree of freedom will be n minus 1, that is 10 minus 1. 10 minus 1 will be 9. At 9 degree of freedom, see this is t table. See, now this is a t table, and in this t table you can see the t critical or t table value at 5% level. So at 9 degree of freedom at 5% level, because we are doing two-tailed analysis, so at 5% level the value will be 2.262. Okay, you can see here it is 2.262 at 9 degree of freedom. You can see that in the table. Now you can compare this table value with the calculated value. So what we observe here, the calculated value is 1.149. Okay, here 1.149, and critical value is 2.262. We find that the calculated value is less than the table value. Okay, so we accept the hypothesis, null hypothesis, that is there is no difference between population mean and the sample mean. So probability is more than 5%. Okay, we can infer that there is no statistical difference between mean hemoglobin content of the sample and the population hemoglobin, that means mean. So thank you all very much for listening to my presentation. Thank you so much.